Large language models, or LLMs, are powerful tools that generate human-like text, but they often make mistakes by hallucinating information or relying on outdated knowledge. To fix this, researchers have developed a technique called Retrieval-Augmented Generation, or RAG, which lets these models pull in real-time data from external sources like the Internet. This helps them give more accurate answers. However, as explained in this research paper by Han Wang, Archiki Prasad, Elias Stengel Iskin, and Mohit Bansal from the University of North Carolina at Chapel Hill, RAG systems face significant challenges when dealing with conflicting evidence. The paper points out that in real-world scenarios, users might ask ambiguous questions, and the retrieved documents could contain conflicting information, misinformation, or irrelevant noise. For example, imagine querying about someone named Michael Jordan. This could refer to the famous basketball player, a computer science professor, or even a fictional character, and the documents might mix up facts, include wrong dates, or add unrelated details. Past studies have tackled these issues one at a time, either focusing on handling ambiguity or dealing with noise and misinformation separately. But this paper takes a more comprehensive approach by addressing all these factors together. To do this, the researchers created a new dataset called RAMDocs, which stands for Retrieval with Ambiguity and Misinformation in Documents. This dataset is designed to simulate complex, realistic situations where queries have multiple layers of conflict. It includes examples with ambiguous entities, where a name or term could mean different things. Misinformation, like incorrect facts that might mislead the model. And noise, which is irrelevant or distracting information that clutters the results. By combining these elements, RAMDocs tests how well RAG systems can handle messy, real-world data, rather than idealized scenarios. Alongside the dataset, the paper introduces a new method called Madam RAG, which is a multi-agent approach to resolve these conflicts. Here's how it works. Instead of a single model processing the information, Madam RAG uses multiple LLM agents that debate the evidence in several rounds. Each agent reviews the retrieved documents and proposes answers, pointing out conflicts and supporting their claims with specific evidence. For instance, in the Michael Jordan example, one agent might argue for the basketball player's birth year based on reliable sources, while another might challenge misinformation from a faulty document. After the debate, an aggregator agent steps in to synthesize the discussion. It identifies the most valid answers, especially for ambiguous queries, where multiple correct responses might exist, and discards misinformation or noise. This collaborative process helps the system handle diverse sources of conflict more effectively. The researchers tested Madam RAG on two benchmarks. First, they used Ambiguous, which evaluates how well a system can present all valid answers for ambiguous queries without favoring one over the others. Here, Madam RAG outperformed strong RAG baselines by up to 11.40%, using both closed-source models like those from OpenAI and open-source ones. Second, they tested on Factuality, which focuses on suppressing misinformation and ensuring factual accuracy. In this case, Madam RAG improved performance by up to 15.80% in absolute terms when using the Llama 3.3 to 70B Instruct model. These results show that debating and aggregating responses can lead to more reliable outputs. However, the paper also highlights that RAMDocs is a tough challenge for current RAG systems. Even the best-performing model, Llama 3.3 to 70B Instruct, only achieved an exact match score of up to 32.60%. This is because the dataset requires handling ambiguity, noise, and misinformation all at once, which overwhelms many existing methods. The researchers analyzed how Madam RAG performs under different conditions, such as when there's an imbalance in the evidence. For example, when most documents support one answer but a few contain critical misinformation. They found that while Madam RAG makes progress, there's still a substantial gap, especially in highly imbalanced scenarios. This suggests that future work needs to refine these techniques to make them even more robust. In the introduction, the paper provides context on why RAG is so important today. It's already being used in popular AI tools like ChatGPT, Claude, Google Search with AI Overviews, and Microsoft Bing Chat. These systems retrieve information from the web to summarize results and answer questions more accurately. But as the internet is full of conflicting and unreliable data, RAG needs to evolve to handle these imperfections. The researchers emphasize that their multi-agent debating approach could be a step toward more trustworthy AI, particularly in applications like deep research, where agents collect and synthesize online sources. One specific example from the paper illustrates this well. For the query, "In which year was Michael Jordan born?" the retrieved documents show conflicts. Document 1 correctly states that the computer scientist Michael Irwin Jordan was born in 1956. Document 2 might have misinformation, claiming the basketball player Michael Jeffrey Jordan was born in 1998, which is wrong. It's actually 1963. Document 3 could add more details about the basketball player but mix in irrelevant facts, and document 4 might be completely off topic, like discussing his college career without addressing the birth year. In Madam RAG, agents would debate these points. One might accept the 1956 date for the scientist while rejecting the 1998 claim as misinformation, and the aggregator would compile a response that clarifies the ambiguity by listing both valid birth years with their contexts, while ignoring the noise. Overall, this research underscores the need for advanced RAG systems that can navigate real-world complexities. By introducing RAMDocs and Madam RAG, the authors provide valuable tools and insights for building more reliable language models. Their work is publicly available, with the data and code shared on GitHub, encouraging further exploration in this area.